Hello everyone, my name is Mrs. Borida Divya, Assistant Professor from the Department of AI ML from B.V. Raju Institute of Technology, Narsapur. So today I am going to deal with the course Discrete Mathematics with the topic Basic Introduction to Discrete Mathematics and the basic concepts in the Discrete Mathematics. So what is discrete mathematics and what are the topics under discrete mathematics? Here we have different topics such as mathematical logic, sets and relation, Boolean algebra, relational algebraic structures, elementary combinatorics and graph theory. So these are the different types of topics or syllabus we have under the discrete mathematics course. Now, why do we need this subject as a part of our AIML or different core subjects? Why discrete mathematics has done and why do we need this subject? So basically, discrete mathematics deals with the logics. It gives a fundamental knowledge about what are the logics we have, what are the algorithms we have, what is meant by set, what are the relations. All these things we are going to get a basic fundamental knowledge from these subjects and a problem solving skills. It enhances our problem solving skills for developing the algorithms and also for understanding the complexities for the computations, whatever the computations we are performing. It gives a basic problem solving knowledge. And it is also useful for the logical reasoning. Example, when you are developing any software applications or when you are developing any programming subjects, so you need to have a logical idea. You need to think logically what are the things we need to apply. So it gives a basic understanding of what are the logics you have to apply in the development of any software product or in verifying your correctness of programs or algorithms. And next, combinatorics. So what is combinatorics and why do we need to study? So this combinatorics, why we need these combinatorics? So combinatorics in daily life we come across what are the arrangements, what are the combinations, how to select choice of some numbers, how to select some group of people. So basic understanding of basic problems comes under these combinatorics. So here we are going to deal about what are the counting problems we have, what are the permutations, what are the combinations. So what is this all? What are the choices of selecting, what are the options of providing something? These are done under the combinatorics parts. Next is graph theory. So why do we need graph theory? Generally, graph theory is using for building a network kind of systems. If you want to create any networking systems or if you want to do any optimizations, because whenever we are solving a problem, so whenever we are developing some code, we generally develop a code. Then we need some optimizations. So for these kind of optimizations and also for scheduling some programs, we come across with this graph theory. So this is a basic introduction about what are the topics we have and why do we need discrete mathematics. Now let's start with first topic. We have a mathematical logic. So what is a mathematical logic and what are the topics involved in the mathematical logic? First we are going to deal with what is the introduction to mathematical logic and what is meant by statement, what is meant by notations and what is meant by connectives, normal forms and what is meant by inference theory and also predicates. So mathematical logic. So what is meant by mathematical logic and what is a logic? In general, what is logic? Logic is nothing but you have to draw the inferences or you have to draw the things from the whatever the facts we have, from that we have to draw the logic. So it is nothing but the principal representation of logic in a very precise and unambiguous way is known as mathematical logic. This mathematical logic is also known as a symbolic logic. So here, what is a statement or what is a proposition? In general, we come across the sentences as in English, right? So what is meant by sentence or propositions? In generally, we have a declarative sentences, that means you are declaring something. So these declarative sentences which are either true or false. That is, a statement must be either true or false, but not both. Those kind of statements or those kind of declarative sentences are known as propositions. That means either the statement must be true or not or false, but it should not be both. For example, here we have an example of 1 plus 1 is equals to 2. 1 plus 1 is equals to 2. Here we can able to say that the condition is true because it is logically correct. And example here, another example is B is a vowel. Yes, B is vowel. It is not, because A is a vowel, B is not vowel, B is a consonant. So here we could able to tell its truth value, whether it is true or false. These kind of representation or these kind of statements are known as propositions. For example, there would be some kind of sentences which we cannot tell whether it is true or false. For example, here we have an example of x plus 1 is equals to 2. Here, unless and until we have known the value of x, we cannot say this statement is either true or false. These kind of sentences can be known only when x value is substituted with some value or when it is quantified. These kind of statements are not propositions. They are not propositions. These kind of statements are known as predicates. So, this is a predicate which can be made into a proposition by substituting some value to the x. For example, when we are substituting x value is equals to 1, then it becomes either true. If we are substituting some value as x equal to 3, then it becomes false. So these kind of statements which can be made either true or false by substituting some value or by assigning some value to these kind of statements are known as predicates. These can be made propositions by substituting these values. So, what is a propositional statement? What it contains? It contains the propositional variables and the connectives. So, what is meant by propositional variable and what is meant by connectives? So, propositional variables are nothing but the propositions. As example, we have seen the propositions as P comma Q. You can define that with small letters P comma Q comma or anything. You can represent that with a small letters. Here, these kind of representations are known as propositions, nothing but statements. For example, P is equals to Ram is happy. So this is one of the proposition or statement I am taking. This is one of the propositions or statement I am taking. Next, let us take one more statement Q. Ram is poor. These are the two kind of statements we have considered. Now, can we connect these kind of statements? These are nothing but variables I said. So, variables P comma Q. And when we are assigning some sentence or something to this, it becomes a statement. So, we can combine these statements by using the connectives. So, these connectives are and, or, not, implication. We have many. We'll see in the coming session. So here, now we have seen that the statements P comma Q we have done, and we have seen some connectives such as and, or, not. Now, these logic, whatever the logic we are using for these propositions, it is known as a propositional logic. Here, we can have a simple statements, which are also known as atomic statements, simple statements or atomic statements, and also compound statements. So, by the term or word, we can say that simple is nothing but it is a one statement. We can use that as a simple statement. Here we have different types of propositions such as simple or compound. So simple statements are nothing but in general, if you are taking individual statements, they are a simple statements. What is meant by compound statement? Compound statement is a statement which is formed from using the previous statements or using the atomic statements along with connectives. So compound statements are a combination of statements along with connectives is known as a compound statements. These connectives here we are calling it as a logical connectives or logical operators. So we'll see what is mean by compound statement. Example. So before that, let's start what are the different types of logical operators we have for combining these atomic statements to form a compound statements. We'll see what are the different types of connectives or logical operators we have. So let's see what are the different types of logical operators we have or logical connectives we have. Here we have symbols, connectives, terms, and examples. So let's see first conjunction. In general, in English, what is mean by conjunction? Conjunction is nothing but you are combining two elements or two statements, two elements or more than two statements using a word and. when you are combining two statements or more than two statements using a word and, then it is known as a conjunction of statements. So here we are representing the symbol with down arrow. Next, disjunction. So what is meant by disjunction? Disjunction is a combination of statements which are combined with word or. When we are combining two or more statements using the word or, then it is known as a disjunction of statement, and it is represented like this. It is called as P or Q, and this is represented like V with V symbol. Next one. So we'll see example. In previous one we have seen that example P, Ram is happy, and Q we have considered as Ram is poor. So when you are using conjunction of two statements, so what it will becomes? P is Ram is happy and Ram is poor. So this becomes the compound proposition of P comma Q. When you are using P or Q, you can simply use as Ram is happy or Ram is poor. Next one is a negation. Negation is nothing but you are using a not symbol in front of a given proposition or a given statement. In front of statement, you are using the word and. That means you are, so not is nothing but a negation of a given statement. For example, here we are considered Ram is happy is a given statement. So its negation will become Ram is not happy. So it is represented like this, or this way we are representing the negation of a statement. Next one is exclusive or. Exclusive or is represented with or symbol with dash. This is known as exclusive or. Here what is mean by exclusive or? By naming we can consider that either any of the combination, either P or Q, but it should not be both. So what is this? In clear we'll understand while discussing with an example. Next one is P implies Q. This implication is also known as conditional. Implication is also known as conditional. So here it is represented like this, P implies Q. This is similar to our English statement if then. Implication is similar to if then. If P, then Q. It is represented like this. Next one is a by implication. By implication is also known as by conditional. So what is biconditional? Biconditional is like if and only if. Here, if and only if you represent like this. So what does this means? This means we write it as P implies Q and Q implies P. If the combination of or the conjunction of implications P implication Q and Q implication P is known as by implication or biconditional. Next one is NAND. So NAND is represented like this. What is meant by NAND? NAND is not of and. NAND is not of and. Next one is NOR. NOR is represented like this. So what is meant by NOR? NOR is nothing but not of or. So we'll have a clear understanding when we'll see one example for this. Here just we have taken a truth values. Generally we have a truth values as true or false. Initially we have seen true or false. So how we'll represent in a digital way or in a numerical way? True is represented with 1 and false is represented with 0. True is represented with 1 and false is represented with 0. So we'll see example for whatever the connectives we are using or whatever the connectives we have discussed in the previous slide. We'll see with one example. In general combination, we'll represent this in the format of P comma Q. We have two terms, right? So when we have only one term P, either we'll have a propositions or truth values as 0 or 1. Here we represent with only 0 or 1. When only we have one proposition. For example, when we have two propositions, we'll represent a 4 combinations. When we have P comma Q comma R, will represent with 8 combinations. So this is the 2 square and 2 cube. So when there is only one P term, we represent with either false or true. When we have two propositions or two variables, we are representing in 4 combinations such as 0, 0, 0, 1, 1, 0, 1 1 like this we are representing. When there are three propositions or three variables, we represent as 0 0 0 0 0 1. So we represent in this way. So here we will see example with only two variables p comma q. Here we have taken p q as 0 0 0 1 1 0 1 1. So what I said, negation is we represent like this, or negation of p. So negation is a not condition of a given statement. Here p we are taken false, so negation of p will become true, and similarly we are writing for all the variables. Next, p and q. So p and q, now we have to remember one condition, that p and q will become true only when both the statements are true, then only it is true. Only when both the statements are true, then only it will become true. If not, it will be false. In remaining all cases, it will be false. P and Q is true only when both the statements are true. Next, P or Q. When will become P or Q true, or when will become P or Q false? For example, here we have the combination 0 0 0 1 1 0 1 1. Here, P or Q will become false only when both the statements are false. In remaining all cases, it is true. That means if one is true and other one is false, then also it is true. If both statements are true, then also true. Only when both the statements are false, then only it will become false. In remaining all cases, it will be true. Next one is P exclusive or Q. So what is mean by exclusive or? It must be either true or false, but not both. So whenever both false and whenever both true, it will be false. So whenever it is true or false or true, it will become true. So that is why it is either or. So whenever exclusive or is nothing but it must be either true or false, but not both, then only it will be true. Next one is implication. Implication is also known as conditional. In conditional, only whenever P is true and Q is false, then only the condition will become false. Whenever P is true and Q is false, then only the whole combination will become false. In remaining all cases, it will be true. Next one is P double implies Q. P double implies Q is, in general, we consider it as P implies Q and Q implies P. We'll consider P implies Q and Q implies P. Then we'll calculate the value of this. Here, for our understanding, when we calculate P by implication, Q will become true when both are true or both are false. We can calculate this using AND condition of P implies Q and Q implies P, or directly we can say that P double implies Q will become true when both are true or both are false. When both are false or both are true, then only it will become true. Remaining cases, it will be false. Next, so this is NAND. NAND is not of AND. NAND is not of AND. In AND, only when both are true, it is true. So it will be opposite of AND. In OR, when both are false, then only it is false. So what will become NOR? Negation of that will become a NOR. These are basic connectives we'll use in the propositions. Now, can we do this for many number of statements? Here we have considered only P comma Q as two statements. But what if we have many statements? P, Q, R is possible. But if in case if our propositions are more and more, can we go with this? Sometimes yes, depending on the given situations. Sometimes it will become for us a little complex to solve the computations using truth tables when number of propositions are more. So in that case, we are going to use the concept of normal forms. So what is normal form? For calculating or for finding the decision of a problems, instead of using truth tables, we are going to use normal forms. So this is normal form. When propositions we are taking more, and when we want to calculate using more number of propositions, it will become for us little typical to use using the truth tables. So we are going to use the normal forms for making the calculations of our decision problems. So when using truth tables, sometimes when number of propositions are more, it will become for us complex to solve using the more number of propositions. At that moment, we are using the term normal form. These normal forms are used for making the decision problems in a simpler way, using the conjunctive normal form, disjunctive normal forms, and we have some other forms such as principal normal form. So, what is conjunctive normal form, what is disjunctive normal form, and what is PCNF and PDNF? We'll see one by one. So, first one is, I said CNF. CNF is a conjunctive normal form and DNF is a disjunctive normal form. Here we will see one by one. So first we will go with disjunctive normal form. So as a term indicates, disjunctive. Disjunction we have seen already that it is a or. We are using disjunction for or. So disjunctive normal form is nothing but it is sum of elementary products. So by the term DNF we say that, or disjunctive normal form, disjunction is or. So here we are using a sum of elementary products, or sum of elementary products is a disjunctive normal form for a given formula. For example, here we have P and negation Q. Here we are considering the propositional variables using the terms and we are making this sum of products. We are making a DNF as sum of product terms. So how we are representing the normal forms? We are representing the normal forms in disjunction or conjunction normal forms. So in disjunction normal form, DNF is a sum of products. For simplification, we can think it is a sum of products, or we know that we represent like this. So this is a or and this is and. So this is a sum of products. This representation is known as disjunctive normal form. Next one is a conjunctive normal form. So what is mean by conjunctive normal form? We know that conjunction is a and. Conjunction is a and. So here we will represent the terms or the given thing as product of sums. We represent this as a product of elementary sums. We will take the variables and we will represent P or Q and Q or OR. We will consider any number of statements. For example, we are considered here P, Q, OR. So what is mean by conjunction? Conjunction is product of elementary sums. So here we have taken an example of this. Here what we have did, it's a conjunction. So conjunction is a product of elementary sums. Next we have PDNF. So we have seen PDNF. PDNF is a principal disjunctive normal form. When we have DNF, again why are we going for PDNF? In DNF we can use a negation or its statements, but in PDNF we can use either a statement or its negation, but not both at one place. So what does that means? Here, if we are considering the example of P and negation Q and negation R, here in this min term is a product. Min term is a product. So either in a min term we can have a statement or any of them. In the another term we have here negation of P, but we cannot have P and negation P at one place. That is a min term. So PDNF is a sum of product of canonical forms, or it is a disjunction of min terms. Disjunction is a sum of min terms. Min terms are products. Here this product should contain a statement or its negation, but not both. Similarly, we have PCNF. PCNF is a principal conjunctive normal form, which is a conjunction of max terms. What is mean by conjunction? Conjunction is a product of max terms. Max terms are nothing but sums. Here, product of sums. We can also tell this as product of sum of canonical forms. It is also similar. Here in these max terms or sum terms should be a variables of P comma Q, whether it can be a statement or its negation, but not both statements at one sum or at one max term. Either we can have only one it's a variable or its negation, but not both. So this is known as principal conjunctive normal form. Here, the dual of a min term is called max term. So what is mean by max term? Max term is a sum of the terms. And what is mean by min term? Min term is a product. So here these both are duals. So duals is nothing but, dual is we are replacing and with or with and. Here we are replacing and with or with and. This is known as duality. So here it is very clear that the max term and min terms are both dual to each other. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.